Today on Monday we will be continuing with the sequence and series lectures. ऊपर में the previously in this topic only today in the previous lectures as we saw some properties. We did some questions on sequence series and some of the properties that we have seen. If each term of an AP is increased, decreased, multiplied or divided by the same number, then the resulting sequence is also an AP. This was a property that we saw in today's lecture only. So let's say the original sequence. This original sequence is A plus D, A plus 2D, A plus 3D. This is our original arithmetic progression. And let's say for the first, we will consider the things like if it is the sequence is increased, each term is increased or let's say decreased. So let's say addition, each term a constant K is added. So the first term becomes A plus K, the next term it was initially A plus D, now it becomes A plus D plus K. The third term, that is A plus 2D, becomes A plus 2D plus K. This is A plus 3D plus K. Can you see that the consecutive differences A plus K and A plus D plus K? It is D, A plus D plus K and A plus 2D plus K. The consecutive difference, the difference in consecutive terms is D. Here also the difference is D. So when we add K to each of the terms, the differences remains the same, that is D only. So the new sequence that we got, this was the new sequence. This is still an AP. This was my original AP. This was my new AP. And this new AP was, this new sequence that I got was still an AP. Geometrically, what it will mean is on the number line, if you want to visualize it. A plus D arithmetic progression, we know that the terms are equally spaced points on a number line. So this A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, and so on. These points are placed such that the distances is same. All the distances between the terms is D only. Now, if you add K, A plus K, if suppose K is a positive number, so each of the term is shifting to the right hand side by a unit K, by the distance K. Each term is shifting to the right hand side by K. This second term A plus D will also shift to the right hand side by K. Third term will also shift to the right by K. Fourth will also shift to the right by K, and so on. So still the new places will still be equidistant only. These are the new places. These are the new places. They all still will be equidistant only, and that new distance will be same as the original distance D. The same logic, the same explanation holds for subtraction also. A minus K, A plus D minus K, A plus 2D minus K, A plus 3D minus K, and so on. Now, what about multiplication and division? If you multiply by a constant K, so the first term becomes K times A, second term becomes KA plus KD, third term is, the original term was A plus 2D. A plus 2D, the original term, when I multiplied by K, so it becomes K into A plus K into 2D. So K into A plus K into 2D I have written. The fourth term will become K into A plus K into 3D. That I have written K into A plus K into 3D. So the difference in consecutive terms, can you see that here the difference is KD? Between third term and the second term, the difference is, sorry, here it is KA plus 2KD, KA plus KD. So here the difference is KD. Here also the difference is KD, and so on. So this new sequence is again an arithmetic progression. This new sequence that we are getting, this is again an arithmetic progression. Just the difference means a slight the difference between the in the case of increasing, changing the terms by increasing and decreasing, and changing the terms by multiplication and division. The only difference is when you multiply by a constant, or for that matter divide also, the new sequence, the new common difference that you have, the new common difference is not, it is different than the original common difference. And in case of addition and subtraction, the new sequence that you have, in that the common difference is same as the original common difference. Here the common difference was D, the new sequence common difference D. In the original, the common difference D. In the new sequence, the common difference is K times D. For division, it will be D upon K. That's it. This is one example. Another, now second property is the sum of two terms equidistant from the first term and the last term is constant. Equidistant from the first term and last term, and is equal to the sum of first and last term. So equidistant from the first term and last term means what? So let's say a1, a2, a3, a4, a5, a6, and so on up to an are the n terms. Okay, so a1 plus an. Suppose equidistant from the first term. So let's say from the first term, I move 1 unit ahead, means I move to the one next term. So the next immediately next term is a2. So a2. So one previous term to an, 1 unit, so it will be an minus 1. So a2 and an minus 1, their addition will be same as a1 plus an. Or for that matter, equidistant. So equidistant term from a1, that is, let's say 2 units ahead, 2 terms ahead. So let's say a2 and a3. a3 I landed at a3 2 terms ahead. So from an, 2 terms previous, an minus 1, an minus 2. So a3 and an minus 2, their addition will be same as a1 plus an. What's the reason for this? So from a1, whatever terms you're going ahead, so for let's say a2, it is a1 addition d, and that many terms you're coming previous to an's, that is an minus 1 we are taking. This an minus 1 is actually an minus d. So this plus d minus d will get cancelled out, and the final addition is a1 plus an only. So when we are taking a3 plus an minus 2, actually what is a3? It is a1 plus 2d, and this an minus 2 is what? Nth term subtraction 2d. So this 2 plus 2d minus 2d gets cancelled out, and what remains is a1 plus an only. So generalized result, I can write it as a1 k terms ahead. So a1 a 1 plus k. This is the 1 plus kth term, and 1 plus k if you're going, so from n k backwards, so n minus kth term, their addition will be same. Corollary of this property, a special application of this property, is the third case. Any term of an AP is equal to half of sum of terms which are equidistant from it. So let's say a1, a2, a3, and 4, an are in AP. a3 will be equal to. Okay, so let me write this property again. Any term of an AP is equal to half of the term, half of the sum of terms. Half of the sum of terms equidistant from it. So let's say if my AP is A1, A2, A3, A4, so on and so on and so on up to AN. So A4, I can write it as, sir, A4 I can write it as, let's say, equidistant term. No? So one term prior, that is A3, one term later, that is A5, one term prior, one term later, and their addition upon 2. Or you can also write it as equal to, so 2 terms prior. 2 terms prior means A2. 2 terms next to the second successive term. Second previous term, that is A2. Second successive term, that is A6. Their addition upon 2. Or for that matter, you can also write it as third previous term. So the third previous term is A1. The third successive term will be A7 upon 2, and so on. The story continues. What's the proof of this property? The proof is very simple. It's very easy. Let's see. A4. The explanation is easy. A4, if I write it as equal to A4, addition A4 upon 2. It's 1, correct? A4 equal to A4 plus A4 upon 2. If I add, let's just addition in the numerator, I add a D and I subtract D. So did I do anything wrong? No. So A4 plus D, and here it is A4 minus D. What is A4 plus D? Sir, A4 plus D is my next term, and A4 minus D is the previous term. So similarly, I could have also written, let's see, A4 is what again? A4 addition A4 upon 2. So this time what I will do, I don't add D, I will add 2 times D, and I will at the same time subtract 2 times D. Means I actually have added 0 only. So when I'm taking addition 2 times D, A4 addition 2 times D, where it is leading me? So it is leading me to 2 successive, the second successive term. Sorry, I made a mistake. It should be the arrow wise, I made mistake, nothing major. Here it is A4 plus D is the fifth, and A4 minus D is 4. So A4 plus 2D is the second successive term. A4 minus 2D is the second previous term. And A1 plus A7 also same explanation. Okay. So if you are able to understand this, the generalized result I will write, sir, nth term. Sir, I will take n plus kth term, means I went k steps ahead of nth term. From nth term, I went k steps ahead. I will also return back k steps from the nth term. They are addition upon and if you are able to understand, this is the generalized result. Again, a special case of this is, let's say, sir, an. I'm just generalizing it result. So for the nth term, if I go, let's say n plus, I go, let's say n plus 2. I can do the variable also, but I'm not using variables. It will become complicated for you. So if I go 2 steps ahead, n plus 2th term, if I take, I also take n minus 2th term. These two will get added. Means right now, don't worry about the equality. These two will get added in pairs. Their addition will give me twice an. And let's say, sir, if I take n plus third, means I go 3 steps ahead. I also come back 3 steps behind nth. Behind nth term, 3 steps. They will get added upon. If I want to make this equality, what should I write upon? The answer, whether it will be 2 or 5, or whether it will be 2, 3, 4, 5 in the upon. Convince yourself that the answer in the upon factor will be 4. Because the first two will get added among themselves and it will give me twice an. The next two will get added among themselves, give me the result twice an, not thrice an, twice only. Why? These two together twice, these two together twice, that is 4 times an, so upon 4. Okay, so it's something like, so don't get confused, like, so here it is 2, 2, 3, 3, so it will be something like 3 plus 2, 5, or 2 into 3, 6. No, nothing like that. Okay, 6 terms I can also take, but 6 should be good, means pairwise terms properly. So 6 pairwise terms if I take, so upon 6 will be the nth term. So this is that property. Okay, and then the next thing we saw was the tricks for solving some questions. So now if 3 numbers are an AP, now this is not the property, it's just a general trick so that it will make your calculation easy. If 3 numbers are in AP, then it is advised to take the numbers as, then the numbers are, take the middle term as A and the first and the last term as A plus D, and the previous term will be A minus D. This makes the calculation easier because this terms A plus D and A minus D, they come in pairs, so the calculation becomes easier. You could have taken, sir, I will take B plus D, B plus 2D. No matter, no one is stopping you from do that, but it will unnecessarily make the calculations difficult. Let's say a little bit lengthy. This property 4 only. Now, if instead of 3 numbers, if I give you, if 4 numbers are in AP, now 4 numbers are in AP, so you have to fill up 4, fill in the blanks. First, second, third, fourth. Now, if you are thinking that, sir, somewhere I will take over here A, then this will be A minus D, this will be A plus B. Okay. So these two have got paired up with each other, but the fourth term will be A plus 2D. So they are not getting paired up properly. Okay. So this is not a recommended way. Better way would be what? This much idea you should have. These two will get paired up among each other, means the second and the third, and the first and the fourth will get paired up. So what I do is, so the second term I take as A minus D, the third term I take as A plus D. If I take A minus D, A plus D, now a common mistake that students do is, sir, here I will take A plus 2D. This is completely wrong. A plus 2D is wrong. Why it is wrong? Because whenever, as soon as you wrote here A minus D and A plus D as a successive terms, so when you wrote A minus D and A plus D as a successive terms, you have made the common difference is equal to 2D. Now you don't have control over that. The common difference is 2D. So since you want the sequence to be an AP, the next term, the common difference is not 2 times D, and then the next term will be A plus D plus 2D. So this will be A plus 3D. A plus 2D would have been wrong. And this, here the previous term will be A minus D minus 2D. So it will be A minus 3D. Yes, now all the terms get paired up properly. A plus D, A minus D, A plus 3D, A minus 3D is making the calculations easy. Okay. For 5 terms, if I tell you, there is a proper pairing, and means there is a proper middle term. The first two gets paired up with the last two, and the middle third position is the proper middle position. So we will start from the third position, fourth position, and second position will get pairs of each other, and fifth and first, A plus 2D, A minus 2D. Here the common difference is D only. Convince yourself for 6 numbers. You can pause the video for a minute and see whether you get the answer right. If 6 numbers in AP. How to do it? You can pause the video for some time and think. So 6 numbers are in AP. There is not a proper middle position. So how it will get paired up? You can see. Convince yourself that this is the answer. A minus D and A plus D. I'm starting from the middle towards the end. From the middle numbers towards the end number. As soon as I wrote A minus D and A plus D, the common difference is 2 times D. So I'm bound to write here A plus 3D, not A plus 2D. Here it will be a minus d subtraction 2d. Subtraction 2d, so it will become a minus 3. Then the next addition 2d, so a plus 5d, a minus 5. So these are some properties of the arithmetic progression. So now let's do some questions over AP. If A1, A2, A3, and so on are in AP, then A8 plus A25 is equal to A11 plus which term? This is your first question. It should not take more than 1 minute. Pause the video, solve for it. You can pause the video, solve for it. I will tell you the answer. A8 plus A25 is equals to A11 plus which term it should be. If you are solving it by the traditional way, so A8, I will write the formula in terms of A plus n minus 1d. Then A25, I will write it as first term plus n minus 1d, that is 25 minus 1 times d. Then A11, I will substitute. And then the suitable, after the suitable addition and subtraction, I will find out the fill in the blank. Then it's a very tedious process. Instead, if you use the picturization of this addition, which property we will be using over here? This property, sum of terms equidistant. Any term of equal, let's say sum of two terms equidistant from the first term and the last term. So the concept involved was here in this property was we move d steps ahead, we come for an minus 1, we come d steps backwards. So that way the addition is preserved. That concept we will be using to solve this question. So here A8 plus A25, 8th term and 25th term, whatever the addition is, I'm not interested in calculating the actual value of 8th term and 25th term, their addition. Now when I'm comparing it with this 11th term, so means actually what I have happened, so this 11 is near to this 8. So can you see that, sir, on the RHS, the right hand side is already 3 terms greater than the 8th term, means vertical section. If I that way, in those way, A6, A7, A8, A9, and so on, where it was A25. When we wrote in the vertical format, A8 plus A25, here it was A11. We already moved so 3 steps ahead to make this A11. 3 steps ahead means 3D. So sir, for the next to maintain the equality, how can you steps ahead? If you want to maintain the equality, you should subtract that 3 steps backward also. You should come back 3 steps behind. So if you come back 3 steps behind, the answer will be 3 steps behind. The 3 steps previous term is 22, means with respect to this 25. Yes, that's it. Direct answer you can get. Okay, this way that question can be solved. If not, this is not a question is not clear, then A8 you can direct substitute first term plus 7d, first term plus 24d, first term plus 10d, subtract, and then you will get first term plus 23d, 21d. That way you can get. Okay. Then second question. The sum of 3 numbers in AP is 24. and their product is 440. The sum of three numbers in AP is 24 and their product is 440. Find the numbers. Pause the video, try for yourself, and then see the explanation. So three numbers are in AP whose sum is 24. So I will not take the three numbers as A plus B, and A plus 2B. Let the three numbers be. Let the three numbers in AP B, which I will take three numbers as some middle term. I will take A, the next term A plus D. So the common difference automatically it becomes D only. The previous term it becomes A minus. Okay. So now applying the conditions, A minus is addition. They are addition. A minus D plus A plus D. Their addition is given to be equal to 24. So this turns out to be 3A is equals to 24 and A is equals to 8. This is the first condition we have used up. And after that, the second condition that he has told is product is 440. Product is 440 means what? A minus D, A plus D is equal to 440. So it becomes A square minus D square into A is equals to 440. So sir, A square, if I just substitute, this becomes 64 minus D square is equals to 440 upon A, that is 8. So 64 minus D square, this turns out to be 55. So D square is equals to 9. So D is equals to plus or minus 3. So the terms will be, sir, either AP1 that we are getting. So middle term will be 8. If I consider D is equals to positive 3, then 8 plus 3. And the previous term will be 8 minus 3, that is 5. So AP2. What is AP2? So middle term will be 8. If I consider that common difference to be equal to negative 3. So 8 addition negative 3, that will be 5. And the previous sum subtraction negative 3. So this will be 11. So ultimately they are the same result. They are the same 5, 8, 11 or 11. So the three numbers will be 5, 8 and 11. Okay. Next question. Four numbers in AP are such that their sum is 20 and the sum of their squares is 120. Find the numbers. Be honest with yourself. Try first you yourself try this question. Pause the video and pause the video. Try yourself the question and then see the solution. Okay. So four numbers are in AP. So let the numbers be A minus D, A plus D. These are the middle two terms. And the next term will be, sir, A. Here the common difference becomes 2D. Can you see the next term and the previous term difference is 2d? The cos 2d is the difference, so the next term will be a plus d plus 2d, so it is 3d, and a minus d minus 2d, so it is a minus 3d. Their addition is 20. So the first condition, that is a minus 3d plus a minus d plus a plus b, and addition with a plus 3d. This is equals to 20. So now can you see what's the benefit of this method? Minus 3d plus 3d gets cancelled. Minus d plus d gets cancelled. 4a equal to 20. A is equals to 5. Okay. The sum of their squares is 120. Sum of their squares, now if I do a minus 3d complete square plus a minus d its complete square plus a plus b its complete square, a plus 3d its complete square. This is equals to 120. Convince yourself. I will just skip one step here. When I will add them, means first you will have to open the brackets, using the binomial and the school property that we use, a plus b whole square. Yeah, a plus b whole square, or p plus q whole square is p square plus q square plus y square. That thing, if you just use it. So in the first, the purples, when I will add a square, a square, a square, a square, everywhere it will be there. So 4a square to definitely rahega. 4a square will come. A square plus a square plus a square plus a square. D square, means the here. In the first, it will be, sir, addition 9d square. Here also addition 9d square. So 9d square, 9d square, 18d square. So here it will be d square. Here it will be d square. So what happened? 9d square, 9d square, that is 18, 1d square and 1d square. So 18 plus 1, 19 plus 1, 20. And then, sir, that is p minus q whole square. So that is, sir, minus 2pq here it is, and here it is plus 2pq. So that get cancelled out. Pq means here actually minus 6ad plus 6ad minus twice ad plus 2ad, that get cancelled out among themselves. So this is the result equal to 1. Substitute a equal to 5. So 4 into 5 square, that is 25 plus 20d square equal to 120. 20d square will be equal to, this is 100. 100 is subtracted. So 20. So d square equal to 1. So d is equals to plus or minus 1. So the 4 terms of the AP sequence 1, if you consider 4 terms of an AP1, so what is the 4 terms? The first term is a is equals to, definitely we have a is equals to 5. So if you consider d equal to positive 1, so 5 plus 1 6, and 5 minus 1 is 4, and then 6 plus 2 8, 6 4 minus 2 2, and AP2. So if it is 5 plus d, if consider d equal to negative 1, so 5 plus of minus 1, that is 4, a minus d, 5 minus of minus 1, that will be 6, and then the term will be here, it will be 8, here it is 2. So ultimately the 4 numbers are you're getting the same result, 4 numbers. Which way you look at it's your preference, 2468 or 864. Okay. Divide 20 into 4 parts such that 20 into 4 parts which are in AP. ratio of product of first and fourth to the product of second and third is 2:3. So again, the numbers we will take a minus d, a plus d. The next term will be a plus 3d, a minus 3d. That this 20 is divided into 4 parts. Okay, these 4 parts we have taken which are in AP, the 4 terms which are in AP. Their addition is 20. This you can see. So the first condition, if I just apply a1 plus a2 plus a3 plus a equal to 20. So can you see if I just add this, this is 4 times a. 4 times a is equals to 20. So the a that we have taken that turns out to be equal to 5. And after that, ratio of product of first and fourth. Product of first and fourth is what? Sir, a square minus 9d. And product of second and third. Product of second and third is a square minus b square. This is given as 2:3. So let's substitute now. So this will be, first we will simplify by cross multiplication only. 3a square minus 27b square is equals to twice a square minus 2. So it becomes a square equal to 25b square. A square is what, sir? If you just substitute a square equal to 25 and this comes out to be 25 d square. So d square equal to 1. So d is equals to plus minus 1. Like the previous question only, the terms, the 4 parts, a minus d, a plus d, a plus 3d, a minus d, this will be the first part. One part will be a minus d. So 5 minus d, that will be 4. A plus d, 5 plus 1 is 6. Then 8 and then 2. Or you get these terms in the reverse order. Okay. Now, the property that we studied, if a sequence is given, if an arithmetic progression is given, and each term is increased or decreased or multiplied or divided by the same term, each term should either be increased by the same, or all of them should be decreased, or all of them should be multiplied by the same number. Then the new sequence is also an AP. Some questions based on that property. Okay, that property will be used in this question now. If A, B, C are in AP, prove that 1 upon BC, 1 upon AC, and 1 upon AB are also in. Pause the video, think for a while, then okay. So if A, B, C are in AP and we have to prove this. So just it's a simple step. Sir, if whether I've already given you the hint what hint I have already given you, that now these questions that I'm giving now, the further questions are based on the property increase or decrease or multiply or divide the original terms by the same number. You increase, decrease, multiply or divide by the original term by the same number, the new sequence is also an AP. So if you say, let's say here A, B, C are in AP. If I multiply each of them, or let's say divide, if I divide each of them by a fixed constant, all of them, then the new sequence is AP. Now the thing is whether in all these questions you just have to understand, means the thing to click means it should come to you. The only thing that should come to you is when the constant that you should choose and which, whether you should add or whether you should subtract or whether you have to multiply by thing or you have to divide by a suitable constant. Okay, out of the four operations, which operation to perform, and along with the operation, which should be the constant. So depending on the target situation, here it is 1 upon ABC, 1 upon AC. I will divide by ABC. If I A, B, C. So if I divide all of them, A, B, C, if I divide all of them by ABC, 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 then the new sequence is also in AP only. I'm dividing all of them by the same ones. Where I'm dividing by the first, what is A upon ABC? 1 upon BC. What is B upon ABC? 1 upon AC. What is C upon ABC? 1 upon A. That's it. Just one step question. Divide by ABC and the problem is over. If ABC are in AP, show that B plus C, C plus A, and A plus B are in AP. These are the new three terms. Think for a while. Okay. So ABC are in AP. What I will do now here is just I will subtract a constant. Which constant? A plus B plus. Here also I will subtract A plus B plus. Here also I will subtract A plus B plus. Same constant I'm supplying from subtracting from all the third. So what the first equation becomes? The first term becomes minus ABC are in AP. Therefore, on subtraction, the same constant, on subtracting the same value from all the terms, the new sequence is also an AP. So now the first term becomes minus of B plus C. The second term becomes minus of A plus C. The third becomes minus of A plus B. These three terms are in AP. So now multiply by minus 1, multiply by same constant, multiply by same constant, multiply by negative 1. So B plus C, A plus, wait, I did some mistake. Yeah, B plus C, A plus C, and A plus B are in AP. True. Okay. If A, B, C are in AP, prove that A square into B plus C, B square into C plus A, and C square into A plus B are in A. Try pausing the video. If you are not able, I will give you a hint. Use this hint. It has something to do with AB, BC, AC. Okay. So now I will explain. If ABC are in AP, then A, B, C. A multiplied by AB plus BC plus AC. B multiplied by AB plus BC plus AC, and C multiplied by AB plus BC plus AC. This will be in AP, yes or no? So what is the first term? The first term it becomes is A square B plus ABC plus A square C. What is the second term? So the second term becomes AB square plus B square C plus ABC. What is the third term? The third term becomes ABC plus BC square plus AC square are in AP. These three terms which are in AP, you can see that sir ABC is present here also, ABC is present here also, ABC is present here also. What is happening by that? I will subtract ABC from all these three terms. This complete is the first term. And this complete first term, complete first term, complete first, third, complete second, complete third term. If I'm subtracting ABC from all of them, the new sequence is again an AP. So the new sequence that I'm getting, is this ABC cut, ABC cut, ABC cut. Means A square B plus A square C as the first term, AB square plus B square C as the second term, and BC square plus AC square as the third term. This sequence is also an AP. So that is what is required of us. Take A square common, B plus C. Here take B square common, A plus C. Here take C square common, A plus B. These three terms are in A. The last question. This question is in your NCRT only. NCRT. If A times 1 upon B plus 1 upon C, B times 1 upon C plus 1 upon A, and C times 1 upon A plus 1 upon B. Are in AP. Then prove that ABC are in A. Okay. So in this question, to solve the previous questions will be used. The previous question number 7, question number 5, and all those things. The previous questions that we solved, make use of those questions. 5, 6, 7. Okay. 5, 6, 7 are the hint to solve this question number 8. Okay, I will solve now. First term is A B plus C upon BC. I just simplified the first term. A into B plus C upon BC is my first term. My second term is B into A plus C upon AC is my second term. And my third term is what? C into A plus B upon AB. This is given to be in AP. Now my target is ABC, so I don't want these denominators. If you can you say that this is upon BC, upon AC, upon AB? I will just multiply all of them by ABC, ABC, multiply by ABC. All the three terms are multiplied by the same number. So the new sequence that I get, that is the new sequence. Here it will become A square B plus C. This becomes B square A plus C, and this becomes C square A plus B. This is in AP. This result we already have, and this result is the reverse of the previous question. Do you see? In the previous question, we solved ABC are in AP. Show that ABC are in AP. Show that A square B plus C, B square C plus C are in AP. Now we have come for the reverse part, that A square B plus C, B square A plus C, C square A plus B are in AP. Prove that the reverse step, that is A, B, C are in AP. So just from the previous question only, you can take the help that on expansion, this is A square B plus A square C. On expansion, this is B square A plus B square C. On expansion, this is C square A plus C square B. This is in AP. What I will do is, so I will just add ABC to all the three values, all the three terms, plus ABC, plus ABC, plus ABC. The new sequence, this is an AP. So what actually is the first term, sir? A common, AB plus AC plus BC. B common, AB plus BC plus AC. Yes, C is common, AC plus BC plus AB. This is in AP. And when this is in AP, you can just cancel out AB plus BC plus AC, AB plus BC plus AC, AB plus BC plus AC. So what remains is ABC in. Okay. So I hope you understood these properties of. The next class we will start with geometric progression. Have a nice day, everyone. Thank you.